based on the same procedure. So now I want you to tell me how to do irrigate tomato. We planted it, we had it two plowing operation, January 15 and February 1st, and we did plantation in February 1st. Planting density 4 plant per square meter for tomato, and this is based on a number that we did an experiment, but you can also use different values or based on your own experiment. And that and urea application are there as well. Harvest is it. So I want you to prepare an operation file for this. Let's do it together. So in the same operation file, نسوي الكاتب منشار ساعات ያለቀ ስለሆነ እንቀጥል ልትራቸው የዝሚላቸው እንዲመጡ ልትራቸው አንድ ሁለት ያው ቋል ዝም ብላቸው back baba ይሄ ታሰቡ እንግዲህ ከዚህ በኋላ የለውም ማን they are responsible okay. Which days did we do plantation? That's 1st of January. Yeah. Right? Year 1, month 1, and 15. January 15 we did a plow. And we need to know that what is the crop ID for tomato. So we go to crops.dat, get files, Yes. Which is 140. So you check the tomato, 72, right? So for you it might be 72, for me it's 73 now. Yeah. So it's fine. If it is 72 for you, we just do 72. So whatever is available in the database, you can select the ID. So in the operation file, the operation file, so in the operation file, so you see that we planted in the January fields. So first year, first month, January 15, we have a plow operation, and the ID for the crop is 73. Another plow is when? It is February 1. Let me do it this way. Side by side. Okay, so February 1. So year 1, month 2, day 1, the same plow operation, same crop ID. Okay, nothing. After this, go back, and the same day, February, it is plantation. So you can remove this plow operation. So I'm removing the plow operation, and this is also fertilizer operation. It is the same day though. Anyways, but to avoid confusion, let's remove the fertilizer operation as well. So we have date of plantation on February 1st. Year 1, month 2, day 1. We have plantation 73, right? And then what we need to provide is a heat unit, right? So how do we compute the heat unit? We have a heat unit calculator, right? We calculate for corn. Go back again to the software, and then potential heat unit calculator. You can open that. If you save already what you test in the previous example, you don't have to copy it again. But if you didn't save it, you can go to the input data and weather data. Again, copy uh, the weather for the Dangla, maximum and minimum temperature. Copy from here and paste spatial and values here. Okay, let's save it so that we have the data for Dangla. And we have to put the date of plantation. What was the date of plantation? It is February. So you write first the month 02 February first, right? 01.
የመጀመሪያው ግን 15 ፌብሩዋሪ 15 ፍሎ 1
So in this heating competition, you only provide planting and harvesting date, not plowing date. When it was planted and when it was harvested, as you see here, plantation date and harvest date. And the second date of harvesting, date of harvesting is when? May 30. May is the May 1? Is it May 1?
yeah May 30
May 30. So May is the 6th month and the date is 30. And make sure it is the same year. It is February to May of the same year. So if you choose 2015, both should be 2015. And the other thing is the crop ID. So the crop ID, you look for from this crop database, from the Excel crop database, not from the one in the folder. There might be some difference. Since it is using the same Excel in order to compute the heat unit, you just use this one. The crop ID for tomato is 72 here. If you remember in our operation file, it is 73. But for computation now of the heat unit, it is using this crop database, the one which is here. So use 72. And it automatically selected this tomato. Okay, and then we have 990 heat unit. So 990, just close that one. Also close the weather and you put 990. So plantation is on February 1st and we have DAP fertilizer application. We know DAP is a fertilizer and we need to know fertilizer ID. We said it is 73, right? 73 is DAP and 65 is urea. So we provide in the operation file, you can just write, click here, go to OPSC if you like to. Then, so in the same day, U1, month 2, and February 1, you have DAP. Fertilizer application is 261, right? And you select the crop here, and you select the type of fertilizer, that is 73, and you provide the amount. Okay, so that's fertilizer application of DAP. In the 1st of March, there is urea application. 1st of March means year 1, month 3, day 1, the same fertilizer application, but the ID is different. This time it is no, this one is crop ID, and it is going to be 65 for urea. The amount is 25 kilogram per hectare. So another urea application in April 1st. 4 months and day 1. Another fertilizer application. Crop the same. ID of fertilizer is the urea amount in kilogram per hectare you put in here. You provide 0 for the rest. Mind you that this plant population was for corn, but for this one I said plant population for tomato is 4. You can provide 14. Now we have 2 fertilizer application, and harvest is in May 10. So U1 month 5 day 30, that's the harvest. Okay, and then in the same date you apply harvest, kill operation. May 30, the crop ID need to be the same for tomato. And now we would like to trigger automatic operation, automatic irrigation. So you will see this is a place, OPP3 is the place to trigger automatic irrigation during plantation, and negative 999 is to just stop the irrigation. So this is plantation time, this one, and OPP3 trigger 1, that is automatic irrigation, and during harvest we write negative 999. This is automatic irrigation. That means it's going to be applied whenever the soil moisture or available water is below the field capacity. So now we have done the operation file with automatic irrigation, and we need to save this one. We write the name here. Let's say tomato, and write it. Right. Now if you see get files, you have tomato.ops. From the sub area file, if you go to the sub area file, okay, and if you go down around here, there is rigidity code. Okay, 0 is flexible or variable application. 1 is for rigid application. If you specify the amount of irrigation, apply this amount of irrigation. So we leave it 0 since we are using automatic irrigation, and we are allowing to apply the amount, the deficit amount. So the deficit amount is different for different time. And this one is a irrigation code. So you have different irrigation code. Let's say we apply the furrow irrigation, which is common in Ethiopia. So let's say first get file and read your own sub area and get to the irrigation code to furrow is 2, right? Furrow is 2. Yeah, furrow of flood irrigation and right. So we did two things. One, we specify the operation file, and in the operation file, we triggered automatic irrigation from planting to harvesting. In the set area file, we allow variable irrigation depending on the deficit, and we specify the type of irrigation to be followed. And two more things is left because we have changed the operation file. We need to record it in the list, right? Like we did before, we need to put it in the list of operation file, and we need to provide the ID in this sub area. So now it is using 140. 140 is a different operation from what we did now. So to see, again we go to I'm working in this folder, I hope. So we select the OPS file, no, the OPSC.dat file. This one, OPSC.dat, and we need to add our operation file here. You can copy this one as we did before, paste it here. Now the ID is 141, let's say, and the name for the operation file is tomato operation file. And you can describe here, like tomato with, okay, automatic irrigation. Automatic furrow irrigation. You can save it. So now we'll be using in the sub area. In our sub area file, we'll be using this operation schedule. So we replace it to 141, right? Huh?
Save file means
Huh?
save file now. Someone replace it.
This one?
Yeah. Tomato is automatic.
This description you can describe anything. This one should be exactly the name that you save the operation file. ID is a number, should not be repeated here. Good?
Yes.
So I wrote 141 in my sub area and write it. So it is, I'm asking to use this 141 operation file. And I'm trying to run it now. So once you run it, now we can analyze our result. The crop yield file needs to be tomato, right? This is tomato, and this is the dry yield. I told you that tomato, most of it is water component, so the dry component is very small. So this is the dry yield, and these are water stress days. You can see that there is no water stress because you did irrigation, automatic irrigation every time. All are the results. Yeah, I'm coming to the irrigation part. So let's go to the ASFI, annual sub area file, and open it. So this is the irrigation amount every year. So about 600 millimeter for the first year, 1992 about 500 something. So depending on the weather and average soil moisture, it depends for the different years. But this is the amount of irrigation applied. Okay, it gives you some idea how much water is needed to apply for the irrigation. So you might take a mean value of number of years, right, to come up with the mean water application needed for your field. Now the water balance completely changes. If you like to do the water balance, it completely changes because you have now the input is not only the rainfall. You know, last time we had rainfall, and rainfall is distributed into the different water balance components, into runoff, percolation, and everything. Now we have two input. Irrigation is an input as well for your field. So you have rainfall in the rainy season, and you have irrigation in the dry season. Then you have this combination of two water inputs, and then the output will be the variables will be different, but the amount of water will be vary because now from furrow irrigation you will have uh, also some percolation, you will have some runoff as well from the irrigation. You can also see that by changing the irrigation type from furrow to drip or sprinkler, you can see how much water can be saved by changing the irrigation type. You would like to see?
Yeah.
So what we like to do is we are using the same operation but changing the irrigation type here. Where is the irrigation type? Here IRR. Let's use drip irrigation, which is 5, and write it. Let's copy first the amount of irrigation from furrow, right? Let's copy and take it to Excel. If you like to visualize, furrow irrigation is the amount 1990, is it 1990 or 80? Started is 1990, 1991. Year. So let's let's use the mean water application for tomato using furrow irrigation. That I'm just using the average of each year. It's like about 540, around 540 millimeters. This is furrow. This is a drip. We have changed here the sub area file to be drip, and let's run it. And the value will be updated automatically. Let us see if there are some savings. So you can see that more than 100 millimeter will be saved per cropping season or one cropping season by just using drip instead of follow irrigation. No, it's about 20. Yeah, millimeter. Yeah. So it's assuming that there is no much loss from the furrow, right? But you can specify here, as we said before, AFI runoff volume to irrigation water apply. Okay. So if for sure the furrow irrigation will have runoff, right? Since it is flooding, we provide 0 here because the model will assume that there is no runoff loss from furrow, but actually there will be a loss as a runoff. If you have some value from literature or other, you can provide these values. For example, maybe 30% is loss, right? They say that furrow irrigation is efficient, okay, up to 60%. That is the maximum. So not only runoff, but there are other losses. There will be percolation loss and others. If we assume that there is a 0.33 loss, let's see what happens. Or 0.3, that's 30% loss. And change the irrigation into 2. And let's see. It's going to be very high. So here, furrow with 30% runoff loss. You can see we need about 770. It's more than 200 millimeter of water needed as compared to the drip irrigation. Are we all at the same point? No? Let me add one thing, then we will work together. And tomorrow morning, also after coffee break, we will stay on this part. Then after coffee break tomorrow, we'll see how to do calibration.
get files below ከዛ በኋላ ሪድ ካልኩ ይመጣል ዶክ 30% ኦፍ ላይ ነው የቀየርከው
30% irrigation loss is here. EFI, where is EFI? Here. Runoff volume to volume of irrigation water applied 0.3 means 30% of water applied is lost in the form of runoff. Okay, let's do this exercise, and then in the morning maybe we do deficit irrigation. የአሁኗን exercise አልጓት this part, no stress. No stress. That's what? Okay. So So ሌላውን እንግዲህ ብዬ no stress means there is no water stress allowed. So whenever there is the water available is below the field capacity, then it will supply water. The model will supply water. Whenever the soil moisture is below the field capacity, that means crop will not be stressed by water. Water stress kaloma in water. We will see how we do the water stress level. Sometimes we do less to 25% deficit, right? That means in that case, okay, automatic irrigation will be triggered when the field capacity,
ያንንም 72
the soil water
ማዶ
level
ያለው
is about 75% field capacity.
ዝቅ በል
Now,
65
whenever
በላይ
it is below,
73 እኮ ነው
the model will supply. But 25% deficit means we allow the model not to supply water until the water level reaches 25% deficit. Or that means 75% of the field capacity.
እስከ ረፍት የነበረው
Ah. So these are the explanation for from OPP
ኦፒሲ ነው
1 to OPP 7.
ያው ይሄን ሶስት ላይ አንድ ታደርጋለህ መጀመሪያ ሶስተኛው ላይ
You add only
ከዛ በኋላ ከመጨረሻ አንድ ከፍ ብለን ኔጌቲቭ 99
this part.
ይሄም የለም
Okay.
ይሄም ዜሮ
And in OPP1 you specify, so in this OPP0 you specify the type of operation.
በቃ
You see here where we did. So OPP0 we specify the fertilizer. Okay. If you have pesticide application also you specify the ID for pesticide. Okay, this is the place where we like to have fertilizer ID or pesticide ID. OPP1 have here also. You can record multiple things here. If you supply fertilizer in OPP0, then in OPP1 you have to identify the rate of application in kilogram per hectare. If it is a fertilizer. But in OPP1 you record multiple things. As you have them here. If it is a fertilizer application, these three are fertilizer application, right? In OPP1 you have to specify the rate. If it is a fertilizer application. The other thing we do in OPP1 is, if it is a planting operation, you specify the heat limit in OPP1. So in OPP1, you specify the rate of fertilizer or rate of pesticide or the heat unit. Right? What about OPP2? OPP2, there is nothing you can do unless you like to change the land use number. If you see here, there is land use number 5. Okay, there is some explanation about the land use at the end of this training material. Okay, this is the land use number. It is associated with carbon number identification. So the model used this land use number and the hydrologic group and also the hydraulic condition and the land cover condition to identify the carbon number. And the carbon number is used to compute runoff and hydrological balance. So in OPP2, we do nothing except you like to change this land use number. Let's say you have land use number 5 now, which is automatically selected. That is control group filtration, okay, and hydrologic group D. We have hydrologic group D, and the carbon number will be identified to be 86. Then if you think that the carbon number is below that, and if you like to change this land use number, okay, you can put it here in OPV2. So I like to use land use number 4, and you provide all the way down and write it. That means instead of using this land use number, the model uses replace value. So this is only to just provide the land use number, nothing else you can do in OPV2. What about OPV3?
E is another.
Here is the description.
Look at this one. E is what it is. I said E.
OPV3, you are here. So you can trigger automatic irrigation in OPV3 and stop it. Okay. So this is mainly for automatic irrigation. If it is 0, that means either there is no irrigation, or irrigation is identified by amount. Okay, by amount means you provide irrigation and the amount of irrigation will be supplied here. In that case, this will be 0. But if you like to use automatic irrigation with stress level or without stress level, then OPV3 is the place where you identify the type of stress condition and the type of irrigation, whether it is automatic or there is no irrigation. Zero means there is no irrigation if you avoid this. So 1 is automatic irrigation. Negative 99 is to stop the automatic irrigation. So this is the place where you put OPV3 is the place that you assign this value for automatic irrigation. OPV4 said irrigation application efficiency. This is also the same thing that we did now. Okay, you can set the irrigation runoff ratio, fraction of each irrigation application that is lost in the form of runoff. So if you like to specify it here, you can specify in OPV4. For example, this is mostly important when you do manual irrigation every time. Done?
Yes.
So for example, if you have applied 10 days in the cropping season, and if you record every irrigation application, and if you like to specify the amount of runoff loss from each irrigation. In the previous example, we have seen 30% of the total irrigation is lost. In this one, you can specify the amount of runoff in each irrigation, if it is for manual irrigation. And it's more targeted to, for example, in day 2 you have applied irrigation, 20% is lost at the runoff. In day 5 you have applied irrigation, 30% applied loss. So you can look at each and every losses for each irrigation application. OPV4 is that. OPV5 is to have the planting density. So population density or plant density can provide here. And OPV6 and OPV7 is that limit the maximum annual nitrogen fertilizer applied for the crop. This is used if you trigger automatic nitrogen fertilizer application. So you can specify that, oh, my nitrogen application will not be more than this. So this is the place you set the maximum fertilizer application. If you are triggering, okay, automatic nitrogen. Okay, I'm stopping. So for our case, so we apply fertilizer on a specified day. No automatic fertilizer application. But if you set to do automatic fertilizer application, you can set the maximum value. Okay. And OPV7 is the heat unit scheduling. So heat unit, if you remember, we have provided the heat unit here, okay, that reached to maturity. But let's say it is harvested before it reaches to maturity. So you can specify here at which percentage of the feed unit does that crop harvested. So the yield also varies, if you harvest it before it reaches to maturity or if you stayed longer. So this is the percentage that's specified. So this is there is in the manual there is a clear description of from OPV0 to OPV7. Good.
And there are crops which are just 2 or 3 times before